When doing malware research, it's good to know how long the samples that you've been analyzing have been in existence. This gives you insight into the time frame of the campaigns associated with said malware. So to help with this, I made a tool called bintime. Let's check it out. Bintime is available on GitHub under the MIT license. This means that you can download, use, and modify any way you see fit. The purpose of bintime is to take PE binaries and pull out all of the associated timestamps in regards to those binaries, creating a range where this binary may have existed. This is important because when you're doing malware research, understanding how old a binary is really useful when attributing it to threat campaigns and threat actors. Typically, people use the compilation time as the time in which the PE was created or the start of that malware activity. However, there are techniques such as time stomping where actors will go in and edit that value to make it look as if that binary was created or compiled at a different time. There are lesser known timestamps associated in the PE structure that may give insight to what the actual creation time for these files are. So this tool, bintime, looks at those and helps determine the best start and end date for malware activity. I wanted to create a tool that would determine the most realistic timestamp range for a PE file. So to do this, I had to extract all timestamps associated with this particular file. That means system timestamps, so the MAC timestamps from the system, as well as the timestamps available in the PE structure using PE file library. Additionally, I wanted to identify any invalid timestamps. So when you look at files that were compiled by the Borland Delphi compiler, you can see that their timestamps are always the same. 1992, June 19th. So anytime that we see that timestamp, we should assume that it's a Borland compiled file and that this timestamp is no longer relevant, as well as doing some simple identification of time stopping activity. Lastly, I wanted to create output that would help me identify the different ranges for each one of these files. So I wanted to create a output for standard out, as well as generate a graphical timeline so that you can see the ranges for each file. To install bintime, all you need to do is clone the Git repo to the system that you want to do analysis from. Then you need to pip install PE file library. To use bintime, you just need to run the script and give it the input. So that could be a file or directory with PE files within it. There are also optional arguments that will help you see more information or get information interpreted a different way. The first is the help option that will print out the usage information, as you see in this screenshot here, as well as a verbose mode that will actually print out all of the logging information as the script is running, a timeline mode which will create a graph, a visual graph of the timeline of those binaries, as well as a full mode. This will display all of the timestamps that were identified. Looking at the code, you can see I used many Python libraries, most of which are available in a standard Python 3 environment. However, as I said with the installation, you will have to install a PE file from pip. I use logging to provide the logging information. And you can see this by going into verbose mode with -v. I also used argparse to create a command line menu. This is an easy way to generate the arguments in command line interface for usage of your scripted tools. Here's my logic for pulling the timestamps from the PE file library. So what I do is I run PE file against the files, Then I iterate through each one of the structures, pulling out any timestamp found. This will create a long list of all the timestamps associated and available in these PE structures. I also created logic for identifying Borland compiled files as well as timestamping. So as we know, the Borland compiled time, 1992, June 19th, is pretty static. So anytime that I see this, I omit it from the range, as well as simple logic to identify timestamping using the compile time versus other times found in the PE structure. Once I pulled all the information I want from a particular file, we will then print out the information via standard out. This information includes the checksum, so a hash of the file, as well as the file name, the alerts, so if it was identified as Borland, there will be alert in this portion, the existence range, so the first and last time it was found via timestamp, as well as if the -f argument was added, all of the timestamps that were found within the PE file structures. Let's take a look at bintime in action. We're going to use a couple different sample sets in order to see the bintime functionality. The first sample we're going to use is Dark Sky. This is a DDoS botnet malware that is actually compiled with Borland. That means that its compile time is going to show the 1992 June 19th date timestamp. But with bintime, we're able to identify this and find a truer creation time for this file. First, we are going to make sure that bintime is working correctly by going to the help menu. And as you can see, the help menu works here. So next we can just run it against that Dark Sky sample. We don't see the Borland timestamp in the start range because the alert says that the Borland timestamp was found and it was omitted from the range. Now, looking at the checksum A02, we can actually go into Virustotal and see some of this information. In Virustotal, you can see the creation time, which is actually the compilation time that it pulls. That is the actual Borland timestamp, that 1992. However, first seen in the wild time is 2010, November 20th. This actually pairs up with our start time for 2010, July 10th, fairly well. Because in the wild time means that it's the first time that Virustotal has been introduced to that sample, which means that there was about a couple months of incubation that that sample was roaming around without being detected before it was picked up. We can get even more information by using the -f option. When you use the -f option, we can see all the timestamps associated with this file. As you can see, we can look at the compilation time, which shows that Borland timestamp. However, all of the image resource directories show the actual creation time, or the more realistic creation time, which is 2010, July 10th. In addition, the MAC time shows a recent timestamp because it was pulled from Virustotal, and so those files are created at that time on my system. We can look at the logging information by using the -v command. And here you can see all the logging information of what the script was doing throughout its processing. This will help if you ever need to debug. Now let's try to run bintime against a directory of files and see how it does. As you can see, we get a lot of output of different date time ranges for the various files in this DDoS folder. This is actually a folder full of DDoS botnets called FlucyHawk, which hopefully will represent a wide range of timestamps for malware activity. Now, this output might be a little bit harder to see and understand just by looking at that, but you can also pipe this out to a file, or you can use the -t option to create a timeline, which will give you a visual representation of the timeline associated with these binaries. Looking at this timeline, you can see that there's 4 of those samples that existed in 2016, and then another 4 that existed in 2017, and then this one outlier sample. This may be an outlier because it doesn't have a compilation time, or the timestamps associated with it aren't realistic enough, so therefore it's basically a scrubbed piece of malware. We can look into this further by looking at the output data for this. So let me rerun this with the -F so that we can see all the timestamps associated. So here's the outlier 9ACC file. We can see that it has the Borland timestamp for its compile time, and then there are no other timestamps in the PE structure. So the only date timestamps that are eligible are the access and create time, which is the reason why it does not have any values in our timeline. This is because this piece of malware is packed. So a lot of the information that would be used to generate useful timestamps for us is actually obfuscated and would need to be unpacked in order to derive. Using bintime, you should be able to get a good and clear picture of when binaries or sets of binaries were created. I hope this tool is helpful for you guys. Thank you very much for your time.